We're Team Pegasus 4, representing the University of Southampton at the 2020 University Rover Challenge. We remain the only team from the UK to have qualified, having had the privilege of competing in the URC for the past 2 years. This year, we intend to return with an improved rover, having redesigned some of the critical systems to make them more robust for the competition.
This year, the wheels are getting an upgrade to reduce the slip from last year. We are using a direct drive system with new wheels. We also have a new airless deformable tire made of natural rubber. It has the benefits of inflatable wheels of molding around small bumps. It's also more resistant to scratches and there's no risk of getting a puncture. The wheels have been made wider to increase grip and the motors are encased by the wheels to protect them from knocks. We carried out a heat transfer analysis to ensure that the motors do not overheat.
As part of the extreme retrieval mission, the rover will make use of a 6 degree of freedom robotic arm with a gripper attachment. The arm has been designed with the 5 kg max weight aspect of the challenge and can lift up to 6.5 kg at full extension. An innovative 3D printed semi-flexible rubber gripper provides excellent friction upon grasping an object, aided by the slight deformation around it. With the camera pointed towards the end effector and the fine motor controls, the arm is capable of picking up heavy weights, grasping small objects, and typing on a keyboard. We are also implementing reverse kinematics to improve arm control and precision.
We upgraded the communication system to increase throughput received at the base station, thus resulting in better rover video feedback quality.
This year, for our electronic system, we have improved the reliability and the safety of all the circuitry inside.
Our main computer is the NVIDIA Jetson AGX Xavier, a computer specifically designed for computer vision applications.
The device will handle the high-level functions of the software system, such as route planning and AR code recognition. For local route planning and obstacle avoidance, we are using a Z stereo camera. For pose estimation, we are fusing data from a GPS receiver, an inertial measurement unit, and odometry data from the wheel encoders using an extended Kalman filter. The stereo camera also provides an additional odometry stream by tracking visual features in its frame. We have implemented AR code recognition. Testing has shown that the system responds to AR codes entering the camera frame. The rover attempts to align itself with the AR code and move towards it. This year, we used MATLAB's App Designer to develop a graphical user interface that displays vital information about the status of the rover. This gives the user better situational awareness than monitoring this information over command line. Also be a secondary input source to use as a backup should the primary input devices fail. We have a 2 degree of freedom camera on the mast of the rover to give us a 360-degree view from the base. The mast camera, drive system and robotic arm can be controlled with gaming controllers.
To identify the possible presence or traces of life, we're using optical imaging. The system utilizes reflectance values from any sample presented to it to match it to a specimen in the database. The system is an interchangeable attachment for the robotic arm and includes 12 pairs of LEDs, whose wavelength vary from ultraviolet to infrared. They are sequentially activated by a local microcontroller to illuminate the sample. An unfiltered, calibrated CMOS sensor images the samples at each wavelength, so spectral graphs can be calculated. The images are processed on board with a k-nearest neighbor algorithm, matched to a mineral database, and those results are sent back to the base station. At base, the data will be evaluated for biological and geological indicators for life, such as sulfates, carbonates, and chlorophyll.
We also plan to test our rover in the Airbus Mars Yard in April. This is the same place that the ESA's ExoMars rover is currently being tested. This will give us experience testing the rover in a tough, foreign environment with a similar terrain to Mars itself. Thank you for watching. We are Team Pegasus.